Hello, my name is Maria Pineda, and today I will be discussing CPI and PPI. For CPI, it stands for Price Index, and it measures the average change in price paid by the consumer. This helps track inflation. PPI stands for Producer Price Index, and it it measures the average change in price received by the domestic producer. This also helps track inflation, but it focuses more on the producer side than the consumer. An example of CPI could be, let's say, the price of eggs, milk, cheese, or vegetables significantly go up due to a drought or, let's say, a supply chain disruption. This will affect consumers. For example, a family that usually pays, let's say, 500 a month for groceries could now be paying 550 for the same products that they normally buy due to the increase from the supply chain disruption. This also shows up in the CPI since it measures the average change in price that consumers pay. An example for PPI could be, let's say, a food processing company that makes bread. Um, let's say the wheat to make the bread has gone up. The producer now has to pay an additional 20% for the raw material, which is the wheat, and an additional, let's say, 10% for packaging, like plastics or cardboard that they use to package the bread. Um, this increase in price for everyday products shows up on the PPI, which measures the price change that producers pay for raw material. If the prices go up too much, then the producer may be forced to pick up prices, and this falls onto the consumer having to pay more. The derivative now, it represents the slope of the original function for each point. As for marginal cost, the marginal cost is the additional cost for an extra unit being produced for a product or a service. In this case, it would be the extra cost for servicing an extra servicing one more consumer, or issuing another loan. The marginal cost is a derivative of the cost function with respect to the numbers of the consumers and loans. This is what we call X. So if the cost function is C of X, then the marginal cost is C prime of X. Suppose that the cost function is C of X equals square root F of X equals G of X. f of x and g of x is the are both different differentiable functions. X represents the number of customers or loans. This means we need to find the marginal cost, which is C prime of X. So now this is a problem that we are going to solve, and the first step would be differentiate C of X, which is the cost function. And then the derivative of the constant 6 equals to 0. The derivative of negative square root f of x needs the chain rule, and this is how you write the chain rule. D equals 1, 2. Okay, where u equals f of x. Now we're gonna apply the the derivative, and it would be c prime of x c prime of x equals x. No, wait. I'm doing this wrong. Two. This changes to f of x times f. This changes to f prime of x. Now we're going to simplify this, and this changes to c prime of x equals negative x, negative f prime of x to square root f of x. So the c prime of x represents the marginal cost, the extra cost of adding one more customer or loan. The negative sign shows that the f prime of x is a positive. I also forgot to mention that the cost is also decreasing because of the square root. And if a function is composed like f of x equals f of g of x, meaning one function is inside another, then the derivative is f of x, no, f prime of x equals f prime of g of x times g prime of x. Now we're going to differentiate the outside function, then multiply by the derivative of the inside function. Now we're going to apply this method to differentiate square root, which is this one, square root f of x, and we want to find d over dx square root of f of x. We're going to rewrite the square root, and this will be so we're going to rewrite the square root, and it'll make it into square root f of x equals of x okay, so this is how you rewrite for the square root, and after that you apply the power rule to this part to differentiate the outer part. That's d times f of x, f prime of x. Okay, so that's how you rewrite it after applying the power rule. After doing that problem, we simplify it to this function, and the final answer would be d dx square root of f of x equals two square root f of x. So this is the final answer. This is how you end up getting the marginal cost. Now, I'm going to answer a few questions. Where is the CPI increasing? The CPI is increasing in the graph when the slope is going upwards, and this is between January and February and a bit of March. Where is the rate of change f prime of x positive? When the graph has a positive slope, it's equal to f prime of x less than 0. And this is between January and February as well. Shape when CPI annual rate is decreasing. If the annual rate of change of CPI is decreasing, this means that the derivative is getting smaller. The slope, the curve might be rising. The CPI curve might be rising, but the slope is decreasing, and this curve is a concave up. Shape when PPI annual rate is increasing. If the annual rate of change of PPI is increasing, then this means that the derivative is getting larger, and the graph is a concave up. Now I'm gonna draw an example of what these look like, what this looks like. So now we could do slope going on. Um, Now for the rate of change for decreasing will look like this. And the rate of change of increasing will look something like that. It's kind of hard to write, but something like that. Now I'm going to finish off with the last couple of questions. What do the slope of the given tangent lines represent? So the slope of the tangent given lines represent the um, the marginal costs at different levels of production. The marginal cost is a derivative of the total cost function C prime of x. The slope tells us how much the cost is increasing. Per additional unit of production at that point. As x increases, the tangent lines are getting they get steeper. This means that the slope increases as production increases. In pretty much in other words, the marginal cost is increasing with production. The previous question that I answered that represent that I was saying as x increases, the tangent lines are getting steeper. That was for the question as production increases, do the slope of the tangent lines increase or decrease? So I talked about that already in my previous answer. I just mixed it with the first one by accident. But the third question is, as production increases, does the production process become more efficient or less efficient for us, for this company? Well, since the marginal cost is increasing, um, the production process becomes less efficient in in a in a efficient production system. Marginal cost will stay consistent or constant, or it would decrease. Now we want to see how microeconomics connects with what we've been talking about. And one of those examples that I got from the video is the concept of microeconomics related to um, the microeconomics um, concept that I feel that was related to this was the law of diminishing marginal return. Um, this states that um, adding more of one input while holding other constant eventually will lead to a smaller increase in output. So that's what I got from the video and what it's related to what we've been talking about. That's pretty much it for today. Thank you for your time. I did have a bit trouble with this one, but yes, thank you for your time.